Okay, I'm going to be referring to this document to do this problem, to do these problems, to illustrate rational inequalities. Okay, the first thing you do is you look for the critical points. One is denominator based, and then the other critical point is done another way. So there's basically two things going on here. The denominator cannot equal 0. You're trying to avoid the denominator equaling 0. When that happens, you have a critical point. So we add 5 to both sides, and x equals 5. The denominator critical point is always an open dot. Always, no matter what. Okay? Oh, the denominator critical point is always an open dot. The other critical point is found by setting the inequality up as an equation. Well, this only happens whenever, well, we can just do x plus 8 over x minus 5 times x minus 5 equals 0 times x minus 5. The truth of the matter is that a fraction only equals 0 when the numerator equals 0. A fraction only equals 0 when the numerator equals 0. Okay? So subtract 8. X equals negative 8. Okay? That's going to be a closed dot because of the or equal to part. Okay, so what we do now is we divide the number line up into 3, using the critical points. We got negative 8, we got 5, we got an open dot. Over the 5, we have a closed dot. We got a closed dot over the negative 8, and an open dot over the 5. Region 1, region 2, region 3. Okay. Next, we test the regions. Test. Region 1, let x equal negative 9. It just has to be in the region. Okay? So I check to be sure if negative 9 plus 8 over negative 9 minus 5 really is greater than or equal to 0. So I end up with negative 1 over negative 14. That's 1/14, which is greater than or equal to 0. That's true. Okay? Next step, we'll test region 2. Region 2 has 0 in it, so we'll use 0. Region 2, we'll let x equal 0. So I want to know if 0 plus 8 over 0 minus 5 is greater than or equal to 0. That's 8. That's negative 5. And that's a negative number being greater than or equal to 0. That's false. Negative numbers are never greater than or equal to 0. Now we'll test region 3. Let x equal, anything after 5 is fine. I'll use 6. So I want to know if 6 plus 8 over 6 minus 5 is greater than or equal to 0. That's 14. That's 1. 14 is greater than or equal to 0. That's true. So, here's what I have. Reconstructing the number line I have over there. Negative 8, 5, region 1, region 2, region 3. These two were the true regions. Interval notation will look like this. We'll still shade the same areas, the same regions. But this open dot will be a parenthesis. This closed dot will be a square bracket. So we have negative infinity to negative 8, union 5 to infinity with rounded parentheses. And that's it. Okay? So now put up example 2. All right. Example 2. We have x minus 13 over x plus 5 is greater than or equal to 7. So the critical points: denominator, and other. The denominator critical point, x plus 5 equals 0. Subtract 5, x equals negative 5. And that's going to be an open dot, no matter what. The denominator is always an open dot. The other is found by making this into an equation. Okay? We're going to clear out the fraction by multiplying by the LCD, which is x plus 5, like so. The x's cancel. The x plus 5's cancel. We end up with x minus 13 equals 7x plus 35. Subtract your 7x. We end up with negative 6x minus 13 equals 35. Add your 13 back. We end up with negative 6x equals 48. Divide off the negative 6. Divide off the negative 6. We have x equals negative 8. It's going to be a closed dot because of the or equal to. Okay? All right. So, we have negative 8, we have negative 5. We have an open dot over the negative 5 because it's the critical point from the denominator. And the negative 8 is a closed dot because of the or equal to. Region 1. Region 2, region 3. And now we'll test each region. Test. Region number 1, let x equal anything before negative 8. So negative 9 is what I'll use. I could use negative 10, negative 11. I could use negative 8.1. Okay, but I'll use the first integer value in the region. So, negative 9 minus 13 over negative 9 plus 5, I want to know if it's greater than or equal to 7. Negative 22 over negative 4. This is 5.5. We're proposing that 5.5 is greater than or equal to 7. That's bogus. That's false. Okay? Region 2. we could use anything between -8 and -5. So -7. So I want to know if -7 minus 13 over -7 plus 5 is greater than or equal to 7. -20, -2, and we end up with 10 greater than or equal to 7, which is true. Region 3. Let x equal 0. 0 is in the region. So I want to know if 0 minus 13 over 0 plus 5 really is greater than or equal to 7. Okay, that's -13 over 5. So that gives me -2.6 being greater than or equal to 7. That's false. So, -8, -5, closed dot, open dot, region 1, region 2, region 3. 1 was false, 2 was true, 3 was false. Okay? So, converted interval notation. We shade the same region. This is going to be replaced with a square bracket enclosing the area, and this will be a rounded parenthesis enclosing the area. So, square bracket, -8 to -5, rounded parenthesis. And there is our final answer. Okay, I'll be putting up example 3 here. After I get this off the board. So we have 15x minus 4 over x minus 6 is greater than 13. So, critical points, denominator, and other. So I got 15x, I got x minus 6 equals 0. So add your 6, x equals 6, and that's an open dot, simply because it's a denominator critical point. Okay, the other is going to be found by doing 15x minus 4 over x minus 6 equals 13. We'll clear the fractions by multiplying by the LCD, which is x minus 6. Cancel, cancel. 15x minus 4 equals 78x. Not 78x. 13x minus 78. Okay. Got x's on both sides, so I'll get rid of this one. 2x minus 4 equals negative 78. Add your 4. 2x equals negative 74. Divide off the 2, divide off the 2, x equals negative 37. And that's going to be an open dot as well. Okay? All right. So, here's our number line. We have 6 with an open dot, and we have negative 37 with an open dot. Region 1, region 2, region 3. So, we're going to test region 1, negative 38. Okay? So I want to know 15 times negative 38 minus 4 over negative 38 minus 6 is greater than 13. I'm going to do the top and bottom separately. 15 times negative 38 is negative 570, subtract the 4. That gives me negative 574. Negative 38 minus 6 is negative 44. So, negative 574 divided by negative 44 is 13, and we got 0, and it looks like the 4, 5 will repeat indefinitely. This is true. Now we'll try region 2. I'll let x equal 0 because it's in the region. So I want to know 15 times 0. 15 times 0 minus 4 over 0 minus 6. I want to know if it really is greater than 13. That's negative 4. That's negative 6. And this is going to be 0.6 repeating. 2/3, which is what this is not greater than 13. That's false. This statement is false. Okay, region 3. 7. We'll let x equal 7. So I want to know if 15 times 7 minus 4 over 7 minus 6 is greater than 13. Now, each one separately. 15 times 7 is 105 minus 4, 101. And that's 1. 101 greater than 13 is true. All right, so here's what I got. I got negative 37, I got 6, open dot, and region number 1 was true, region number 2 was true. So, negative infinity to negative 37 describes this interval. 6 to infinity describes this interval. And ladies and gentlemen, that's a wrap.